Welcome back to Josh Does Math. In this video, we're going to be doing the chain rule a couple of times. So we're looking for dy dx for each of these cases. So for the first case, y is equal to x to the fifth minus 3x, all to the power of 4. So as you can see, we can view this as an inner function and an outer function. So you could view this as f of x, and then you could view this up here, this f of x to the fourth, as being g of x. So you see, you can view that as an inner function and an outer function. So the chain rule says that we can take the derivative of g with respect to f of x times the derivative of f of x with respect to x. And that's the same thing as taking the derivative of g with respect to x. So this allows us to break up our composition of functions a little bit. So a clever way to say this is just derivative of outer with respect to inner times derivative of inner with respect to x. So that's what we're going to do with this first case here. So we get dy dx is equal to derivative of inner with respect to x. So that's going to be the derivative of whatever's inside the parentheses with respect to x. And that just turns out to be the power rule twice. So that's what I get. Now I need to do, so I handled this part of it, df dx. What about dg df, the derivative of this thing to the fourth power with respect to this thing inside? Well, that's just going to be the power rule. Pull the power out front, one smaller on the power. And on the inside here, it's not just x, it's going to be whatever was on the inside. Now, I just simplify this down. And I don't think it really simplifies. And you say dy dx. Maybe move the 4 to the front. And that's about all you can do. So this is dy dx. How about for the next case here? We can do the same thing. We can say dy dx is equal to d whatever's on whatever the whole function is, x squared minus 2 to the 500 with respect to whatever's on the inside times the derivative of whatever's on the inside with respect to x. And as you can see, if you were to view these derivatives as fractions, you could cancel these and say, oh look, I'm left with the derivative of whatever I originally had with respect to x. So you're not allowed to just cancel those as fractions, but that's just a helpful way to memorize the steps that you're taking here to set up your chain rule. So let's see, what's the derivative of this whole thing with respect to what's on the inside? Well, that's just going to be the power rule. 500 times whatever's on the inside to the 499 power. How about the second factor here? Well, that's just going to be the power rule again. So I'm left with 2x, and that's it because this is the derivative of a constant. So then I can say that this is equal to 1000x times x squared minus 2 to the 499. That's going to be my final answer for that one. Dy dx is equal to that. So that's how you use the chain rule on a couple of these composition of function problems. You just identify what your inner function is and identify what your outer function is, and then use the formula. Thanks for watching.